The Integrated Drive Generator, IDG, provides electrical power for all the aircraft systems, and therefore its reliability is of the utmost importance. It consists of a generator and a constant speed drive, CSD. The CSD converts the variable input speed of the engine into a fixed rotation speed for the generator. Thus, the generator is able to provide a fixed frequency for the aircraft electrical network. Like blood in our body, oil is the key component of the IDG. It is used for cooling and lubrication, but it is also a hydraulic fluid used by the CSD to mechanically regulate the rotation speed of the generator. So you can see just how mechanically complex the IDG is. The IDG is driven by the engine accessory gearbox. It is accessible in the engine nacelle. The reliability and the efficiency of the IDG depend on the cleanness and the correct quantity of oil used. The oil level is controlled via the sight glass. The cleanness of the oil is ensured by taking some precautions, which are described in the AMM procedure. The contamination of oil with water or dust can cause premature filter clogging, excessive wear of the IDG, and overheating conditions. Oil cans and tools should be kept in a clean and dry environment. It is preferable to use a new can of oil when you service the IDG. The IDG oil system consists of the IDG itself, an external cooling circuit, and the IDG oil cooler. Let's take a look at how the oil circulates in the IDG oil system. You recognize the IDG system. The IDG, the external cooling circuit, and the IDG oil cooler. During operation, the oil is pumped out of the IDG to be cooled down in the cooler. Then the cooled oil comes back into the IDG. During servicing, the oil is pumped through the IDG pressure fill port. It goes through the IDG filter and exits the IDG into the external circuit, flows through the external circuit, circulates into the cooler, flows through the external circuit, and comes back into the IDG case. Now the IDG case is being filled with oil. Once the oil level exceeds the top of the overflow standpipe, it flows outside the IDG through the overflow drain port. The top of the overflow standpipe corresponds to the top of the green band of the sight glass. The servicing procedure is aimed at filling all the cavities of the circuit with oil, expelling air pockets, and thus setting the optimum oil level. If there is too much oil in the IDG, the operating temperature increases, and there is a risk of IDG disconnection in flight. A low quantity of oil may be at the origin of a low oil pressure and electrical frequency fluctuations. The generator may be lost in flight. After correct servicing, the optimum oil level is at or near the top of the green band. On the A330 and A340, there is an oil level sensor. If the oil level is in the lower part of the green band, low oil level detection may be generated in operation, leading to additional burdens for the maintenance and flight crews. Now let's go back to the aircraft to service a genuine IDG. Read caution notes and follow the AMM procedure step by step to ensure that the entire IDG oil system will be properly filled with oil and all air pockets are expelled. Put a container under the IDG to collect the oil that will overflow during the servicing. Remove the dust cap from the overflow drain port. Connect the overflow drain hose on the overflow drain port. This action will depressurize the IDG. Some oil may come out of the overflow drain hose. Ensure that the tube is not bent and the end is not immersed in the oil. Remove the dust cap from the pressure fill port. Connect the pump onto the pressure fill port. Fill the IDG with oil at a maximum of 35 psi. Ensure that there is enough oil in the pump reservoir in order to avoid the introduction of air in the IDG oil system. Use a transparent tube to control the condition of the oil during the IDG filling. During servicing, the oil enters the pressure fill port and crosses the filter, flows through the external circuit and circulates into the cooler, flows through the external circuit and comes back into the IDG case. Keep pumping. The IDG case is then filled with oil. Once the oil level exceeds the top of the overflow standpipe, it flows outside the IDG through the overflow drain port. Keep pumping to fill the entire oil circuit and expel air pockets from the system. Stop pumping when the quantity of oil collected at the overflow drain hose exceeds 1 liter or 1/4 of a US gallon. The oil will continue overflowing until the level has dropped down to the top of the overflow standpipe. While the oil is overflowing, remove the pressure fill hose. Install the dust cap on the pressure fill port. Once the oil level has reached the top of the overflow standpipe, the oil stabilizes at its optimum level at the top of the green band. When only drops of oil come out of the overflow drain hose, remove it. Install the dust cap on the overflow drain port. Do an engine dry motoring or start the engine at idle for at least 2 minutes to allow the oil to circulate through the system and ensure that every cavity of the oil system is properly filled with oil. Let the oil level settle down for 5 minutes. The oil may be slightly above the top of the green band due to thermal oil expansion. However, the oil level may have dropped due to the presence of air in the system before the motoring. Look at the oil level sight glass again to ensure that the oil level is optimum. Good servicing is a key factor in ensuring a smooth and long IDG operating life. It contributes to the operational reliability of the aircraft.